For each vector field in the curve C oriented in red, so these red paths are C, determine the sign of the line integral. Well, before we do this, you have to know that u dot v, the dot product, whose definition is that it's the norm of the two vectors times the cosine of the angle between, means that it's going to be 0 if theta is 90 degrees, because cosine 90 degrees is 0. And if it's positive, that means the angle would be less than 90 degrees. And if angle is bigger than 90 degrees and less than 180, then because cosine is negative, the dot product will also be negative. Now, the reason this is important is because whenever you're going around like that, and if your vector field is somewhat in a similar direction, that means that the dot product will be positive. Okay. On the other hand, if you look at here, the vector field f is going up, whereas the path dr is going right? So you have the vector field f and dr being 90 degrees. So in this case, the integral will be 0. Okay. So for this first example, this integral will be 0 because the vector field is going up, whereas the line is going right. On this side, the integral will be positive because it's going this way, whereas the line is going that way, so the angle is less than 90 degrees. And when it goes down here, the direction of the path is going down, whereas the vector fields are going left, so again it's 90 degrees, so it'll be 0. So overall, it will be adding 0 and then plus and then 0. You're adding these three things, and therefore you're going to get positive value for the line integral. Let's see what happens for the second example. For this second example, I see that these vector fields on this larger circle, it's always perpendicular to the path. So at any moment, dr, which is the small increment in the path direction, and the f, which is the vector field, they're 90 degrees, so over here it will be 0. The same thing happens for the small circle. The only time that this is not 0 is these two, because on here, as you can see, as it goes up, this is the vector field is in the same direction as the path there you're integrating, whereas on here, as you go this way, the vector field is the opposite direction, so it'll be positive and negative here. Here the vector field and the path, the orientation of the path and the vector field is in the same direction, and the orientation of the path and the vector field is in the opposite direction on this side. Furthermore, if you look at the vector field carefully, maybe it might be hard to see here, but these vectors are in some ways it's symmetric. So it's there's a symmetry. The vectors going this way and that way are exactly the same. So although this is positive and this negative, these two will cancel each other because they have the same amount. So it's going to be 0. Okay, so it will be 0 for the outer circle, 0 for the inner circle, and then plus and then minus added, and they cancel. And because they cancel, the answer would be 0. Okay, what about this one? Well, so for this one, over here, the vector field is going left, whereas the path dr is going right. and their angle is bigger than 90 degrees, definitely. So over on this side, they're going opposite directions, so the line integral will be negative valued, right? Whereas going this way, you see that as you're going this way, the vector field is going left and your path is also going left. So over here, you're going to get positive. So now you're going to wonder whether it's going to be the same case as before, where here they were exactly the same thing but opposite signs. Is that the case here? Well, here it's not the case because over here the vector fields are larger, so this line integral on this part will be very negative, whereas over here when you integrate, the vector field is very small, right? These are very small, so although you do the dot product, the dot product will still be kind of small. And because negative is big, whereas the positive one is small, you're going to get negative as the line integral value. Okay? Alright, so hopefully these examples made you realize what to use in order to determine the sign just by looking at the graph. Sometimes you might have a question just like this, like true or false, or figure out if it's positive, 0, or negative. Or sometimes you might have just an honest equation that you integrate, but if you also have the graph, you can also figure out whether your calculation is right or wrong by looking at the graph. So in both cases, being able to judge the sign of the line integral using the pictures, that's a very important skill.